Hi everybody. For this video I'm going to talk about the biasing transistor. As the simple circuit for biasing transistor, what you can see is that you're going to have transistor. This one I used Q2N2222, and I also have a collector resistance R2, base resistance R1, emitter resistance R3, and I also have the supply voltage. I use this one as 15 volt. So let's take a look quick before we move to using LT Spice 4 to analyze the circuit by biasing transistor. Okay, we have three basic equation for transistor, and for the equation 1 I apply KVL. I take a look at this loop. Okay, from the top pass to base resistor, and also emitter resistor. So when you apply KVL, you know that this is your VCC, right? The supply voltage, and that's going to equal R1 IB, right? Or IBRB, and then you have the voltage difference between the base and the emitter. So I have this one as VBE, and then you also plus IE, emitter current, multiplied by RE, and you also know the relation IE equal to IB plus IC, and also IC equal to beta 0 IB. Okay, what we're going to do next is that we're going to look for IC. So what I'm going to do is that I'm going to write IC in the term of VCC, RB, VBE, and RE only. So you have to write IE and IB in the term of IC. It's just the simple math. So you take a look at this quick. You have IC in the term of VCC, RB, VBE, and RE. From equation 1, from 3, you know that IB equal to IC over beta 0, and then from 2, IE equal to IB, which is equal to IC over beta 0, and then plus IC. So you have IE equal to IC multiplied by 1 plus 1 over beta 0, and then you plug in IC in equation 1. Sorry, you plug in IB and IE in the term of IC in equation 1. So I end up with the IC. You just need to rearrange equations, so it's not that difficult. So I end up with IC equal to beta 0 multiplied by VCC minus VBE divided by RB plus the beta 0 plus 1 and multiplied by RE. And then if you want to see the variation of IC due to a variation of RB or RE or beta 0 or VCC, for example, if you want to see IC due to the variation of RE, you simply differentiate, partial differentiate IC with respect to RE. So this is what we're looking for, IC. Okay, now let's move to P-Spice. I'm sorry, LT Spice 4. This is I used the P-Spice, so it's easy to see the current and the voltage. flowing through the circuit. Let's go to RT space, and then I put new schematics. So you start drawing circuit. I need the ground, left click and right click, stop placing. I need 3R, right? So I need to rotate, so you move right here, rotate, and then you can, oops, sorry, I don't need to rotate, so I can undo and then start pick up resistor again. So I need 3 resistor, and then you also need the voltage source. So I go to components here, I have voltage source here, so it's become a DC voltage. And I also need the transistor, which is to be your NPN transistor. Okay, I hit OK, and then you right click on the transistor to pick new transistor. In this case I'm going to use 2N3904. So I got my NPN transistor. The next step is you need to rearrange your circuit and make connections, right? So I'm going to F7, move components. So I put the ground down here, and then let's put this guy up there. Oops, sorry. And also collector resistance I put up here, and this is my emitter resistance I put down here. Okay, now we're ready to make connections. So you pick up wire. So let's go to the very quick make connection. You connect to the source voltage. You connect this one to the ground. We can move that later on. And then oops, let's pick up again. We make connection with emitter resistance, and then this is your collector resistance, and this is your base resistance. Let's move the ground again. So I hit the left click, and then I do the rest of my connections right here. Okay, now we need to set up the voltage. I'm going to use 15 volts. So you right click on the voltage source and you type in the number 15, and then let's change the value of your R. For this one I'm going to use the 910 for the base resistance. Click OK, and then for the collector resistance I used 3K, and then for the emitter resistance I use 560. Okay, just right click and type in the number. The next step to analyze the circuit, I'll need to set up label to be easier, you know, to see what the name of the voltage. For this one I'm going to use this as the, let's change this one first. For your resistance you can change this one, the name, just right click on the letter. So I use this one as RB, and then right click on R2. I'm going to use that RC, collector resistance. And for oops, sorry, emitter resistance, I use RE. You also can label this one has to be the base. Label net. Okay. So use this one as the base. Click OK to put this one on the line, and then you put this one as the collector, right? C. And then for this one is the emitter. You right click on the line and the label net, and this is your emitter. You click OK. Oops, I just undo it. Okay, let's do again. Label net, and this one become emitter. You hit OK. Alright, let's click to place emitter there. Next step is that you need to go to setup window. Actually, you want to analyze the circuit. You want to see current and the voltages in the circuit. So what you need to do is you go to edit, and then you go to PSPI directive. Actually, we do this one later on. You want to analyze the circuit, you just go to PSPI analysis, and then you go to DC operating point. You click this one and you click OK. You're going to have a window show up. Okay, I did already. So what you need to see the information, the current and the voltages in the circuit, is that you go to view. Sorry, okay, you want to see the current and the voltages in the circuit. You simply go to menu or simulate and run. You're gonna have a window pop up, and this is your voltage and the current. You have IRE, IRC, IRB. Okay, you can analyze that by yourself. I'm not gonna explain at this point. You also can change the operating temperature by going to PSPI directive. Okay, in case you want to see your operating temperature a different one, you simply, let's say at 70 degree, you just hit .temp, and then that's mean temperature, and then 70. Just hit OK, and this one give you information that you're working on temperature at 70 degree. And then you just do a simulation again. This is your voltage and the current at 70 degree. Okay, and you can also vary your, let's say, RB. For example, you want RB to be plus and minus 5% of 910 ohms. You simply go to SPICE directive, and you type in dot step para dot step param, that stands for parameter, and then you put RB. That's what you to vary, and then you minus 5% of 910. That's equal to 864.5. Okay, and then you also plus 5%. That's give you 955.5. Okay, and then you just click OK, and then you do the same thing. You go to simulate, run. That gives you information about when your RB vary from 910 minus 5% and 910 plus 5%. Okay, you can also play around with the gain of your transistor. Okay, you want to see what the current and the voltage will be if you use their different gain. You could do the same thing. You go to PSpice Directive S, and then what you need to type is that you put dot step. That means you want to vary your gain, and then you also need to put the device NPN and space. You put the number of your transistor. That's 3904, and then you want to vary, and you need to put also BF. That means you are interested in gain, and then you put list, and then you put 100, 200, and 300. So you have different gains. You hit OK, and you hit the simulate again, run. So this is your new voltages and your currents. Okay, so that's the biasing transistor using our LT Spice 4 to analyze the circuit, the very simple circuit. Okay, bye.